Okay, hello gang. We are going to work through some of the review questions. I'm going to work through some solutions and post them up on YouTube, and then if we do not have time to go over all of them in class, you will have access to a worked out solution for some of the problems. So I'm going to start with simply doing problem number 4 of the review questions that are due this week. I'm going to read you the problems first. It says, a student heats calcium carbonate to produce calcium oxide according to the following reaction, which I've already listed on the board. If the student starts with 100 grams of calcium carbonate and makes 45 grams of calcium oxide, what is his percent yield? So that's our problem. So let's jump in and see if we can figure out how to work this one out. Now the first thing you need to think about in this problem is, again, same thing I tell you all the time, what have they given me and what am I trying to find? And what pieces of information am I missing to get to that last step? So we're told that we're starting with 100 grams of calcium carbonate up there. We're also told that the student makes 45 grams of calcium oxide, and we're asked for to find his percent yield. Now, if you see over here, I have listed the formula for percent yield. Percent yield is actual yield divided by theoretical yield times 100%. Now, what's important that you understand about this is that one of those numbers you are going to get through experimentation. That happens through actually producing something. What is that? That is your actual yield. This happens through experimentation. The other number is called theoretical yield. That is a number that is derived theoretically. It is the one that we are going to find using stoichiometry. Okay, and how would we find that number through stoichiometry? Well, here's how that would happen. They're telling us we start with a certain amount. Now we know from what you've learned in chapter 7 that in a balanced chemical reaction, there are relationships that exist between all of the substances. So if I started with this amount, I can relate that, not through grams, right, but through moles, of course, with any other substance in the balanced chemical reaction. So if I take this thing here and somehow get it into moles, then I can relate it to moles of another substance, which I can then, of course, relate back to grams. And that number, once I relate it back to grams, is what we call our theoretical yield. That's what we should get if we do the experiment perfectly. Does that make sense? So let's jump in and do that, okay? So here are the steps. Actually, let's step back a minute. So we have been given, so let's see here. We've been given that he makes 45 grams of calcium oxide. What is that? In terms of percent yield and my equation, think for a minute. I told you that one of those is determined through experimentation, right? This 45 grams is what? Of course, it's my actual yield. This is my actual yield, okay? So it would go right here. And then to find the percent yield, the only other amount that I need is my theoretical yield. And I already said we would find that using stoichiometry. So we're going to go ahead and work through all the steps of solving this so you see exactly what we're doing. You ready? Here we go. Okay, so I've got 100 grams of calcium carbonate. If I'm going to use stoichiometry, I've got to get that turned into moles. If you can see up here that I've already determined the molar mass of calcium carbonate. I have 1 atom of calcium, 1 atom of carbon, and it's CO3, so I've got 3 atoms of oxygen. When I add all those up, I get a molar mass of calcium carbonate of 100.09 grams, okay? So now we're going to go ahead and take our 100.0 grams of CaCO3, right? That's the amount we started with. For every 1 mole I have to have of calcium carbonate, I have to have 100.09 grams. And when I do that math, I've got 4 sig figs. My final answer is going to be 0.9991 moles of CaCO3, of calcium carbonate, okay? So that's the first step. And now, to go from moles of calcium carbonate to moles of calcium oxide, I have to look at my balanced chemical reaction and see what the relationships are. So let's look up here. For every 1 mole of calcium carbonate, I'm going to produce 1 mole of calcium oxide. It's a 1-to-1 ratio. Okay, so we're going to go ahead and work it out. 0.991 moles of calcium carbonate for every 1 mole of calcium carbonate. You can see I'm putting it on the bottom. Why? Because I want to cancel it out. I will produce 1 mole of calcium oxide. So then I will also have 0.9991 moles of calcium oxide. Okay, that's step 2. And the third step is that I got to go from moles of calcium oxide to grams of calcium oxide. Again, you can see up here I've already calculated my molar mass of calcium oxide. Hopefully that's second nature by now. Look at the periodic table. 1 atom of calcium, 1 atom of oxygen. One mole of calcium oxide is going to be 56.08 grams right here. Okay, so I don't have a mole, I have 0.991 moles, 991 moles, so 0.9991 moles of calcium oxide. I find that for every 1 mole, that relates to 56.08 grams. So the amount of calcium oxide that I actually produce is going to be 56.03 grams. Okay? If I produce 100%, if my theoretical yield is, if my yield is perfect, right? Theoretically, I would get 56.03 grams. That is my theoretical yield. Okay, I'm trying to find a pen that's the right color to mark that. Here we go. Okay, so this here is my theoretical yield. Okay, that's what I should produce. Now I'm going to take the actual yield, which they gave me up here, compare that to my theoretical yield, and multiply that by 100. Okay, so let's go ahead and do that now. To get our percent yield, that's just how I'm writing it, is, again, the actual yield, 45.0 grams of calcium oxide, divided by the theoretical yield, what I should have produced if I did it perfectly, which is 56.03 grams of calcium oxide times 100%. I have only 3 sig figs here, right? So my final answer can only have 3 sig figs. So when I do this math, I get 80.3%. So my percent yield for this problem would be 80.3%. Hopefully that makes sense.